Hey, what's up guys, this is Jawad and I brought another video. So this video is going to be very interesting, and this video is on EtherChannel. EtherChannel is very important technology in Cisco, so I'm going to represent how the EtherChannel works and some explanation. So let's get started. This is also known as a link aggregation. This is a definition from book. This is not my own definition. That means where we aggregate different links. And Ethernet is a technology that enables multiple physical link into one link, which increases bandwidth of your link by providing redundancy. So what it does actually, let's suppose if you are looking on the diagram, let me get my pen. So if you're looking at this diagram, you can see I wrote here these two boxes here, and the first box says let's suppose you have a fast Ethernet channel, and on the fast Ethernet channel it works like a 12.5 megabyte per second. It transmits data from one workstation to another workstation. That means it tells you the total time when you download the data. That's the reason. And the second, if you are on a gigabit link, gigabit mean you are on 1000 mbps link. Actually you cannot transmit data 1000 mbps per second. You can transmit data like 125 MB per second. So what is that technology? The technology is, let's suppose you have two routers, switches, switch 1 and switch 2. Now what you want to do, actually, let's suppose you run very sensitive type of environment, like where you don't want to face any downtime and you want to keep it up all the time. So what you are gonna do, let's suppose you are running different services. If I say a website, a gaming service or anything, and you don't want any downtime on your link, so you create another link. So the first link you had created is called primary link, and the second link you will create is going to call secondary link. So what happened, let's suppose you lose one link, even though if for some reason your first primary link went down, the secondary link would work automatically. So that way you don't need to worry, you don't need to rush and run for the configuration. So you can also say this is also a backbone or backline for your switch, and this is a really good technology, and I would suggest everyone to create that technology on all switches. I mean, not all switches, if your work environment requires you. And then the second thing is, I wrote here 8 and 16 physical interfaces. So in Ethernet technology, if you are talking about Cisco routers, the Cisco routers, they usually support only 8 links. But if you are working with other technology, other vendors, then you can go beyond the 8 limit and you can aggregate 16 links at a time. And this is my definition down there, which says Ethernet converts secondary link into the primary link. This is very basic definition. And let's suppose if you are getting 125 mbps, then that's mean if your both link are working at a time, that mean you are getting 250 mbps. It also increases bandwidth of your connection. Let's suppose you are running a video channel or you are transmitting a video data or something like that, then this technology really matters. So from there we will go to the packet tracer and we will perform our lab. But before going on our lab, I would like to show you some of the 3 protocol or the types Ethernet channel which you can configure on your router depending on the vendor and on the model. So first one, which is a very basic, is called on. So on is actually a very basic. Let me delete everything. I just wanted to clean my window. So some of the, it's a static ether channel. Why we call it static? Because you just set up on one router and on second router, and then you don't need to do any configuration. It requires less configuration. And the second thing, it's not automatically, the router is not gonna look for other routers, and the definition is the same: convert secondary link to the primary, and it uses a group numbers and support 8 links. So down is our configuration. We will talk about the configuration when we will perform our lab. The second type is PAGP, or you can say PAGP. I don't know how you are gonna pronounce it, but it's up to you. So this is actually a dynamic ether channel, converts secondary link to the primary, and this is a Cisco owned protocol. That means you will find this protocol only in Cisco routers, and you will not see this protocol in any other router, vendor's router. So this is all configuration for switch 1, switch 2. We will see that configuration. And one thing I wanted to say over here, let me show you. Okay, if you are looking, it says auto desirable. So on link on first router, you are gonna say auto, either you are gonna say desirable. Okay, you will say desirable on first router. So the first router, when you set it desirable, it will look for the other routers. I mean, it starts looking around. That's why it is called dynamic protocol. It starts looking in the neighbors routers and everywhere. If there's any router set to auto, so I can create a link with that router. So if it is auto and desirable, that means it's gonna work. If it is, let me clean, and if it is desirable and desirable, that's good. It's gonna, if you set both routers on desirable, so both routers will look at each other and create a link. But if you set both routers on auto, that's not gonna work. Third and very important protocol, which can run on Cisco as well as on any router, is called LACP. Maybe you can say LACP, I don't know. So dynamic ether channel, the same thing, open standard found in all routers, uses group numbers, port 16 links. This is the major difference. So you need to remember this thing. Let's suppose if you go into the interview and they ask about these things, you should remember these things. And then the configuration, so it uses active passive. If one is active and the other one is set to passive, let's suppose the first router set to active, it will start looking for any passive router. So the same thing, if both are set to active, they are gonna work. But if they both are set to passive, they are not gonna work. And at the end, this is the command to see your configuration for Ethernet channel. So let's go to the packet tracer and see our first lab. Thank you. So guys, I'm in the packet tracer and I'm going to perform the lab. So this is the moment of truth. We are going to configure 3 protocols. The first protocol is on. So let's get started without wasting any time. So we will go to the router 1. Please do not follow this configuration on the right, because this configuration I had done this before and it's not completed. You should follow me right now, and you will have all the configuration. So all you need to do is go into the CLI and then go to privilege mode, and then you can say configuration mode. In the configuration mode, you are going to interface. Which interface you are going to go? Okay, let me get my pen ready. Here you go. It should be red type. Okay, these 2 interfaces. So the first interface is going to, as I can see, this interface over here. It's a gigabyte interface. We connected gigabyte interface, both interfaces. So we will go to the first interface, which is going to call interface G0/1. We are going to define range over here. Like, let's suppose if we have more than 1 interfaces, then we should write down G0/1 and then the G0/2. So we are inside the interface and we are going to type in channel group, and we need to provide the group number, which is going to 1, and then we are gonna say mode on. So this is going to define, you see over here, state is up. It's going to configure on protocol, and then we can exit out and we can say do show EtherChannel. And over here you can see the group state is L2 maximum ports, maximum groups we can assign. Right now the 2 ports we aggregated 2 ports, but we can max port, we can aggregate 8 ports on these switches. And then this is our group number over here, and then we are going to perform the same configuration on our second switch. So we will go to the switch, and the switch over here we configured it successfully. And after some time we will see these 2 lights should be green. Okay, let me see, let me fast forward it. This is little slower. Okay, here you go. So as you can see, now this light turns on. That means our on protocol has been configured successfully, and these lights are on. That means the both channels are working and we can transmit max data on both channel. And so the first thing is we should go back to our switches, and where we define the ether channel over here we should write down no, we don't want the on protocol, so we are gonna say no. Let me see it again. Okay, so yeah, so we need to go back to the interfaces. Interface range 0/1 dash 0/2. Let me see, 2. So I'm going to write G, I'm going to, it's a gigabit, and right now I'm going to write this command, no channel group 1 mode on, and here you go, I removed it from switch 1. Now I will go back to the switch 2, and you see this is orange. to our configuration mode, and we are gonna say ether channel. We should not see anything, so it says 0. That means no port has been aggregated over here. So if it says 2, that means 2 ports has been aggregated. And the same thing if you run the command over here, and you run the command do show, so we don't have any protocol working on here. So we will go on the second protocol, which is a PAGP, and then we just need to go back to our router first. Let me go down, exit out from, and it's the same thing. You need to go to the interfaces, the same interfaces, 1/G0/2, and then you have to write down channel-protocol. Instead of writing the group, you are going to say protocol and PAGP, and yeah, so this is how we activate the PAGP on our switch 1. And then we will write down the second command, channel group, the same command. Group is going to be 1, and then mode is not on. We are gonna say desirable. Desirable means this switch actually wanted to look for another neighbor where he wanted to connect, and wanted to make a configuration on PAGP. So over here we ran this command, and we are in the good shape. So if you write down do show ether channel, you can look over here. You have 2 ether channels here, and the protocol name is PAGP. Sorry about that. And then you will go back to the second switch, and second one, desirable auto. We are going to define the second router auto. We can define as a desirable. I told you in the theory, if we keep both as a desirable, that means still they are going to work, but we are going to define one as auto. And over here we exit out, and then we will fast forward. So here you go. So both of them now are connected, everything is green. Go back to the router 1, and we need to remove our protocols. So I'm already inside the interfaces, and over here I'm gonna say maybe this is the channel protocol. I can say no. So what we are already inside the interfaces. I'm not going to write down, I'm just going to use the same channel protocol, and then we are gonna say LACP. So LACP we are going to define, and then we are gonna say the same command. It's a desirable, but over here we are gonna say channel 1, group 1, mode active and passive. So I'm going to make this router active, and the second one would be passive. So we are done here. If you do show ether channel, you can see I aggregated 2 ports over here. And then we need to go to the second switch. On the second switch we are already under the So I'm going to write down the same command. We are already under the interfaces, we don't need to write down again. So instead of PAGP, we are going to say LACP, and then from there LACP to we are going to say the second command, channel group 1 auto. So this is going to be passive. We can set both switches on passive and still they will work, but no, sorry, active, still they can work, but we cannot set them as passive. And here we go. So we will exit out and we will ether channel, and as you can see it has not configured, something is gone wrong, so I need to look again. Maybe I need to do a fast forward. Okay, so let's go back and type the same command. No, it has not configured, something wrong. Let's go back to our interfaces. On the interfaces we are going to say we are going LSCP. We will define the protocol. Rejected, part of channel with different type of protocol enabled. Rejected, so it is saying is already part of channel with a different type of protocol. So this is also a part of different protocol, it's not letting in. So first thing we need to turn that off, whatever protocol is set. We are gonna say no, and then we are gonna set it again. It's doing the same thing. So we are gonna say exit out, do show EtherChannel. So the PAGP is still there, we need to remove this PAGP. So what I'm going to do, I'm going to both interfaces, and then we need to write down a command PAGP, and I'm going to say no PAGP. Here you go, and exit out, do show EtherChannel. Now you can see we removed it successfully. We are going to run a new protocol, LACP, and sorry, I wrote it wrong. It should be LACP. It should be channel. We are not removing, we are. And the first thing we need to go to the interfaces. Every time I forget to go to the interfaces, and then LACP, and then we are going to write the biggest command. Okay, we can type in. So we can write it down, channel dash group, and group number 1, and mode. What mode is going to be? Passive. And now I do show EtherChannel. So here you go. So we already set it. So you are seeing over here, I'm going to fast forward. Okay, here over here, so it's connected. So this is our EtherChannel and 3 protocol. We can set 3 protocol on the EtherChannel. If you do like my video, please subscribe my channel and stay connected. Thank you so much. Have a good one. Bye bye.